Hello students, welcome to my class. In this video we are going to be discussing about energy, power, intensity of the wave problems and superposition of the waves related problems and reflection and refraction of the waves problems we are discussing. Let us see the first question in the first concept, energy, power and intensity of the wave. The first question says the tuning fork of frequency is given as 440 Hz is attached to a long string of linear mass density is given as 0.01 kg per meter. So here it's a linear mass density is given as 0.01 kg per meter, and here its frequency is given as 440 Hz it's given. Under a tension of here it is given as 49 newtons is given. The work produces the transverse waves of amplitude is given as 0.5 millimeter on the string. So here string now it is producing the transverse wave of its amplitude is given as 0.5 millimeter. So here it is 10 power minus 3 meter you can take. Now here at what average rate is the tuning fork transmits the energy to the string they are asking. Means indirectly they are asking the power they are asking. Energy by unit time they are asking. It's nothing but power you will be calculating. So the average power formula will be getting as this is 2 pi square f square a square into you will be getting as mu into v will be getting. So here you just substitute these values. Here you will be getting as 2 into here 3.14 whole square, and the frequency here it is given as 440 Hz is given. So you can take as 440 whole square you can take into amplitude is given as 0.5 millimeter, and here even you can write it as 5 into 10 power minus 4 you can take. This is whole square a square. Mu is given as 0.01 linear mass density, and here velocity is given as this is here you can take velocity just calculate students. This is nothing but here will be getting as v equals to root over t by mu is the formula velocity of the transverse wave, which will be equal to tension is given as this is 49 newtons is given by here mu is the linear mass density. Here you can take as 0.01 under root you can take. So when you are bringing this side numerator, here it becomes 10 power minus 2, and here it will becomes as 10 power 2 you can take. So here it is you can write it as velocity will be 17 meter per second will be getting. So this one you just multiply, then average power the value will be getting as nearly here this is 0.67 watts will be getting when you are calculating this value. So this is the correct answer. Let us see the next question. A transverse wave of amplitude is given as 0.5 millimeter and frequency is given as 100 Hz is produced on a wire stretched at a tension of 100 newtons. If the speed of the wave is given as 100 meter per second, what average power is the source transmitting to the wire? So here average power they are asking students. Average power formula will be getting at this is 2 pi square f square a square into mu into v you can take, and here with this here velocity you can take as root over t by mu. This is under root you can take, which is nothing but here instead of mu linear mass density is not given. So here when you are squaring this one, here will be getting as root t by mu. So instead of mu you have to put the values t by v square you have to substitute. Then here will be getting as therefore the power average power will be getting as 2 pi square f square a square mu in the sense here you can take as t by v square into you can take as v you can take, one v gets cancelled. Then here you can take as 2 pi square f square into a square into t by you can take as v you can take. Now here you just substitute this value students. Here average power which will be equal to 2 into this is 3.14 whole square into, so frequency is given as 100 Hz is given. So here you can take as 100 whole square into a square. Amplitude is given as 0.5 millimeter. So here you can take as 5 into 10 power minus 4 whole square you can take, and tension in the string is given as 100 Newton is given. Then this is a 100 newtons you can take by here velocity it's given as 100 meter per second. So here you just cancel all these things, students. Here 100 gets cancelled. Here we'll be getting as, so this is 2 into, this is nearly 9.85 will be getting into here, this is 10 power 4 into 5 5 is 25 into 10 power minus 8 you can take, and here this is 10 power 4, and here it becomes 10 power minus 4, and 225 will be getting as 50 into, this is 9.85 into, you can take as 10 power minus 4. So here when you are calculating this value, nearly will be getting as 4.9 into, you will be getting as 10 power minus 2 watts will be getting. So this is the first answer, is the correct answer. Let us see the next question. The next question says here, a 200 Hz wave with an amplitude is given as 1 millimeter travels on a long string of linear mass density is given as 6 gram per meter. So here linear mass density you can take as its mass per unit length, and here it is given as 6 gram per meter. So 6 gram per meter it's given, and here here you can take as, this is 6 into, you can take as 10 power minus 3 per kg per meter you can take, and its frequency is given as 200 Hz is given, and here under the tension of 60 newtons is given. So the first question they are asking us here, A we just calculate, find the average power transmitted across the given point on the string. The average power formula will be writing as, this is 2 pi square f square a square into, you can take as mu into v you can take, students, and here this is velocity is not given, and here 2 pi square f square into a square into mu value you can take a square into, here 2 pi square f square a square into mu into v. So mu into velocity, here velocity is nothing but, here you can take as root over t by mu. So this is root over t by mu you can take, and if you are taking this mu inside the root, in the sense here it becomes mu square into v by t by, here will be getting as mu will be getting. So one mu gets cancelled, students. Here you can take as 2 pi square f square a square into, you can take as mu into t you can take, these two things it will be under root you can take. So you just substitute this value, 2 into 3.14 whole square into frequency is given as 200 Hz, this is whole square, into amplitude is given as 1 millimeter, it's 1 into 10 power minus 3 meter, millimeters you have to convert, this is whole square into mu into t, linear mass density is given as 6 gram per meter, and here under root you can take 6 into 10 power minus 3 into, you can take as tension it's given as 60 newtons. So when you are simplifying this one, here will be getting as nearly 0.47 watts will be getting. This is the first question. Second question they are asking, the find the total energy associated with the wave in a 2.0 meter 2 meter long portion of the string. So here power equals to, you can take as energy by time. This is here energy they are asking, energy which will be equal to, you can take as power into time you can take. So time in the sense here distance covered by the wave, which will be equal to p into, here you can take as distance covered by the wave by, or its length by, you can take as speed you can take, students. Therefore here energy which is nothing but, here you can take as, so this is p into L by v, in the sense here you can take as root over t by mu you have to take, students. And the power we have calculated already 0.47, and here it's given string length is given as 2 meter long it's given, so into 2 you can take by, so tension is given as 60 newton by linear mass density is given as 6 gram, that is 6 into 10 power minus 3 you have to take, under root you can take. Now here you have to cancel, students, 10 times, here 10 power minus 3 when it goes to the numerator, 10 power plus 3 will be getting 10 power 4, so here you can take as 0.47 into 2 by square root of 10 power 4, in the sense 10 square you can take 100. So here when you are simplifying this one, here the energy value, so here this is 10 power 2, so 47 2 0 will be getting as 94, and here this is nearly will be getting as 9.4 into 10 power minus 3 joules will be getting. So this is the energy value. 9.4 into 10 power minus 3, and here second option is the correct answer. Let us see the next question. A sinusoidal waves 5 cm in amplitude are to be transmitted along the string having a linear mass density is equal to 4 into 10 power minus 2 kg per meter. So it's a sinusoidal waves of 5 cm amplitude is given, students, and here it's a linear mass density is given. Amplitude here you can take as 5 into 10 power minus 2 meter, and its linear mass density is given as mu, which is nothing but 4 into you can take as 10 power minus 2. If the source can deliver a maximum power of 90 watts, so here its a power is given as, here it is 90 watts is given, and here the string is under the tension of, here it is given as 100 newtons is given. Then the string highest frequency at which the source can operate is. So power formula, you know, students, here average power, the formula will be getting as half into, this is here in terms of, you can take this is right frequency they're asking, right? Frequency in the sense, here you can take as an average power formula will be getting us, here average power, the formula will be getting us 2 pi square f square a square into, you can take as mu into v, you can take, students, and here is nothing but f square. F we require, right? With this, here you have to calculate mu is given, and here velocity we don't know, v equals to, here you can take as root over t by mu, you can take, which is nothing but t is given as 100 newtons by linear mass density will be getting as, it's a 4 into 10 power minus 2 is given. So here 425 times, so here 25 into 10 power 2 it becomes into 10 power 2, here it will be under root, so velocity will be getting as 5 into 10 power 1 will be getting. So here velocity will be getting as 50 meter per second will be getting. With this, here you have to calculate f square, which will be equal to p average by, here you will be getting as, this is 2 pi square into a square into, you can take as mu into v, you can take, students. That's nothing but, here will be getting as p average will be getting as 90 watts by 2 into, here pi square value, here already it's given as 10 is given, so here you have to substitute, into amplitude is given as 5 into 10 power minus 2, so here you just square that one, 25 into 10 power minus 4 into mu value is given as 4 into 10 power minus 2 into, here v is given as velocity calculated as 50 meter per second. So here you have to simplify this one, student. F value here, this is 25, 4s are 100, 100 and 10 power minus 2 gets cancelled, and here 2 into 50, 100 will be getting, 100 into 10 will be 1000, and here it 10 power minus 1. So now when it goes to the numerator, here will be getting as f square, which will be equal to 10 power minus 1 in denominator, so here it becomes 900. So frequency value will be getting as 30 Hz will be getting. So this is the correct answer. Let us see the next question, students. Here a steel wire has a mass is given as 5 gram per meter. That doesn't mean here it's given as linear mass density is given. Mu is given as 5 gram per meter, 5 into 10 power minus 3 kg per meter you can take, and is under the tension of, here it is given as 450 Newton it's given. Find the maximum average power that can be carried by the transverse wave in the wire if the amplitude is not exceeded 20% of the wavelength. Amplitude here it is not going to be exceeding 20%, means 20 by 100 into its wavelength you can take 21 times. Here it will be amplitude is nothing but lambda by 5 you will be getting. Instead of lambda, even you can write it as v equal to f lambda, and the lambda equals to, here you can write it as v by f you can take. So here it's nothing but, here 1 by 5 into, you can take it as v by f you can take. Now here let us take the substitution, students. Average power, you know the formula, which will be equal to, this is we can take here so 2 pi square f square a square into here will be getting as mu into v you can take. So now here you have to substitute, students. Here frequency they are not talking, and right. So here you just substitute this value, students. Here you will be getting as 2 into here this pi value, pi square in the sense 3.14 whole square will be getting 3.14 whole square into you can take as frequency whole square. So this is f square you can take, and here amplitude square you can take. Amplitude is nothing but here it's given already, which is nothing but this is amplitude square. I am just taking the square. It's 1 by 25 into here you can take as v square by f square you can take into here you can take as v you can take. It's a v you can take. Here this f square gets cancelled, and here you have to substitute these values, and this is 2 into here this is 9.85 into here 3.14 whole square by 125 into here will be getting as v cube will be getting. Now first you have to calculate v equals root over t by mu will be getting, and here 450 Newton by mu value you can take as this is 5 into 10 power minus 3. So here 5 90 times 90 into 10 power minus 3, and here it will be getting as 90,000. So here velocity will be getting as 300 meter per second will be getting. You just substitute this value, students. Here or else here this one you can make as 10 you can take. This is on here you can take as 9.85 you can take as instead of this one 10 you can take into this is 20 into 1 by 25 into v cube in the sense 300 whole cube we can take, which is nothing but 20 by 25 into here 3 cube in the sense 27 into here will be getting as 10 power 6 will be getting. So here you can take as 5 4s and 5 5s will be getting 4 into 27 will be getting as 108 will be getting. And here you will be getting as by 5 into here you can take as this is somewhat 100 you can take, students. 100 into here you can take as 10 power this is 2 pi square f square a square into v, right. Here you can take as 10 power 4 you can take 520 times it is going. Pi square f square a square 2 pi square f square a square in the sense 1 by 25 into v square by f square into velocity. Here we are getting as v. So this is 2 into this value is 10, and here it will be 1 by 25 into v square in the sense v cube will be getting, and here one more 10 will be there, students. Here we forgot this 10 value. 2 into 10 it's okay 20 by 25 into 327. This is 5 4s 5 5s 27 and 4 into 27 he will be getting as it's 108. So here we will be getting as 108 by 5 into we will be getting as 10 power 6 you will be getting. This is 10 power 4 you can write 520 times, and here this one you can write as 108 into 20. To mu square 2 q square, so v square by 5 5 is 25 f square. And by 25 this is p average you can take, students, so you can calculate. Wait a moment, here somewhere we have done mistake. So velocity you got it as here we will be getting as 300 meter per second. Then here you can take the average power formula will be getting as P equals to, here you can take as, so 2 pi square F square A square into 2 pi square F square A square into mu into V you can take, and here you can take as 2 into 3.14 whole square into F square is nothing but F square, you just keep like that, and A square will be there. A square in the sense here you can take as this is 1 by 25 into you can take as V square by F square you can take. Here we forgot this mu value, students. Mu into, here you can take as V you can take, and here this F square gets cancelled. Here you can take as 2 into 10 into, this is 1 by 25 into V square into V cube will be getting. So here mu value, here we forgot, here mu will be getting as 5 into, this is 10 power minus 3 you can take, students, and here you can take 5 times, here 5 2s will be getting, and 2 2s will be getting as 4 will be getting 4 into, this is V cube in the sense here you can take as 300 whole cube we can take, students, and 4 into, this is 27 into, here you can take as 10 power 6, and this is 108 into 10 power 6 will be getting, and here it's nothing but 10.8 into 10 power 4 watts we can take. So 10.8 into 10 power 4 watts is the correct answer. Let us take the next question, students. Two waves in the same medium are represented by the verticals in the figure. Find the ratio of their average intensities they are asking. Average intensity ratios in the sense here you can take intensity, how it is related to the frequency and amplitude in the sense intensity here you can take, students, which is directly proportional to F square into A square you can take. Here the first wave frequency is given, and here it's going to be completed one oscillation. So one wave it's going to be giving one oscillation. So here that will be getting as 1, and second wave is going to be completing, this is the first wave, and here it's going to be completing 2. So F1 will be getting as first wave is completing one oscillation, and here second wave it's going to be completing 2 oscillations, and here first wave amplitude is given as 5. Amplitude of the first one is given as 5 units we can take. Here they are not talking about anything, and amplitude of the second one you can take as, this is 2 meters or 2 units we can take. Now just take the ratio, students. I1 by I2 which will be equal to, this is here you can take as F1 into F1 square into A1 square by F2 square into A2 square you can take, which is nothing but F1 by F2 is nothing but 1 by 2 whole square, 1 by 4 into A1 by A2 in the sense 5 5 is 25 by 4 you can take. So this is nothing but 25 by 16 is the intensities ratios will be getting. I1 by I2 which will be equal to 25 is to 16. This is the correct answer. Let us see the next question, students. Two waves are represented by the following equations, are traveling in the same medium. Y1 is given and Y2 is given. It's 5 sine 2 pi into 75t minus this value. Y2 is given as 10 sine 2 pi into 150t minus 0.5x. The ratio of the intensity they are asking. So here you can be writing as here intensity, here it's a omega 1 it's given as, in the first equation omega 1 is given as 75 students, and omega 2 is given as, here it is 150 is given, and here the first one amplitude here it's given as A1 equal to 5 and A2 you can take as 10 it's given. The ratio of the intensity means intensity here in terms of angular frequency the relation will be getting as omega square into you can take as A square. Then it's nothing but I1 by I2 which you can write it as omega 1 square by omega 2 square into you can write it as A1 square by A2 square you can take, students. So omega 1 in the sense here you'll be getting as 75. It's 75 by 150 whole square into you can take as A1 by A2. Here you can take as 5 by 10 whole square you can take 75 2s, and here 5 2s will be getting, it's nothing but 1 by 4 into 1 by 4, which is nothing but we can write it as intensities ratios will be 1:16 is the correct answer. Now let us see the next question, students. A spherical source of power 4 watts and frequency is given as 800 Hz is emitting the sound waves. The intensity of the wave at a distance 200 meters. So a spherical source of power is given, and here it is emitting the waves which has the frequency is given as 800 Hz. Now here intensity of the wave at a given distance formula will be, intensity is nothing but energy crossing per unit area and unit time. Energy by time you will be calling as power you can take. Instead of this one you can take as power by area. Area in the sense here you can take students 4 pi r square. Now here you just substitute the value. Power is given as 4 watts is given by, so 4 into here you can take as 3.14 into r square. R is nothing but distance is given as 200 whole square. 2 2s are 4 into you can take as 10 power 4. This 4 gets cancelled. So here you just substitute value 10 power minus 4 it becomes, and here you can take 4 4s are 16 in denominator, 4 1s are 4, it's 5, this is 12.56, and here into 10 power minus 4 you can get. So when you are simplifying this value, here we will be getting as nearly, so 1 by 12.56 when you are going to be simplifying, here we will be getting as nearly 0.079 like that we will be getting. So together you can take 7.9 into 10 power minus 6 watt per meter square is the correct answer. Which means approximately you can take students 8 into 10 power minus 6 watt per meter square you can take. So first one is the correct answer. Let us see the next question. The next question says here, a point source emits sound waves equally in all the directions in a non-absorbing medium. 2 points is given as P, Q are at the distances 2 meter and 3 meter respectively from the source. The ratios of the intensities of the waves at the point P and Q they are asking. So here intensity ratios in terms of the distances is here I is here you can take as inversely proportional to R square you can take students. Is nothing but here I equal to here they are not talking about the point source is going. Point source here it is going to be emptying the spherical wave fronts. So here we will be getting as I equal to P by 4 pi r square we will be getting. In the previous question also we have seen, then I is inversely proportional to r square we will be getting with this expression. R is nothing but distances is given, and here ratios you can take I1 by I2 which will be equal to you can take as R2 square by R1 square you can take, which is nothing but, so here this is 2 meter is R1 and 3 meter is R2 you can take. Here this is nothing but, so 3 by 2 whole square you can take, which is nothing but 9 by 4 will be getting. So it's an I1 by I2 ratio will be getting as 9:4. Let us see the next question students. The intensity of the wave from a point source at a distance is given as 2 meters is 1 into 10 power minus 2 microwatt per meter square is given. The intensity at a distance of 10 meters they are asking. So point source here, for a point source intensity the formula will be getting as I equal to P by 4 pi r square will be getting. So here I is inversely proportional to intensity value is given, one intensity value, and I is inversely proportional to r square you can take students. And here you can take I2 by I1 which will be equal to you can take as, this is R1 square by R2 square you can take. So here R1 value is given as 2 meters. So here you can take I2 which will be equal to I1 into you can take as R1 by R2 whole square you can take. I1 it's given as 1 into 10 power minus 2 microwatt it's given. You just convert this one students, 10 power minus 6 watts. R1 is given as 2 by 10 whole square you can take, 2 5 times. So here it becomes 10 power minus 8 into here you will be getting as 1 by 5 whole square means 1 by 25 you will be getting. So here when you are simplifying this one, here 1 by 25 means 0.04 you can get into 10 power minus 8. So here you will be writing as right here this one you can write it as students 4 into you can write as 10 power minus 2 into 10 power minus 2 into 10 power minus 6 you can take students. Here it's nothing but 4 into 10 power minus 4 microwatt per meter square will be getting. So this is the correct answer. Let us see the next question students. If the amplitude of the wave is double and the frequency is reduced to 1/4, the intensity of the wave at the same point will be there asking. So intensity here in terms of amplitude and frequency the relation will be getting as I is directly proportional to a square f square you are getting students. And here the ratios of the intensities when you are taking, here you can take as a1 by a2 whole square into you can take as f1 by f2 whole square you can take. So here the amplitude of the wave is double is given. So here a1 by 2 times of a1 you can take whole square, and frequency is given as, here it becomes 1/4 is given. That means here f1 by 4 it will come to the numerator, and here you can take as whole square. f1 gets cancelled, a1 gets cancelled. This is 1 by 4 into, you can take as 4 square, it is nothing but 16 you will be getting, and 4 times. So here they are asking I2 value. I2 is nothing but, this is I1 by I2, then it's nothing but here I2 by I1 you can get it as I2 equals to, here will be getting as I1 by 4 will be getting. So intensity is going to be reduces 1 by 4 will be getting, decreases by a factor of 4. This is the correct answer. Let us see the next question, student. The displacement time graph for the two sound waves is given, A and B are shown in the figure. Then the ratio of their intensity is IA by IB they are asking. So here you will be getting as A and B it's given, and here A amplitude is given. Amplitude of the A is given as 2, and amplitude of the B is given as 1 meter it's given, and here it is an amplitude maximum displacement, and here it is a amplitude will be getting, and here now here it is. So frequency when you are talking, so here it's going to be completing one wave, and here it is going to be completing half of the wave it's going to be completing. And now here you can take, this is how it is related in the sense, right, or else omega you can take, students. Omega is an angular frequency, it's nothing but here will be getting as omega A by omega B ratio will be getting as A to the B ratio. So omega A is going to be completing half of the wave to the omega B will be getting. Omega here it is going to be completing one full wave, B if you are considering as 1, in that A it's going to be completing half of the wave. So here omega A by omega B when you are taking this, here you can take it as 1 by 2 by 1, you can get it as 1 by 2 will be getting, students. And here amplitude of the A to the amplitude of the B you can take, which is nothing but you can take it as 2 you can take. So I is directly proportional to, here you can take it as A square omega square, and even omega in terms of frequency also you can write, students, half of the frequency it's going to be completed. And here let us take here, this is I1 by I2 which will be equal to IA by IB, which will be equal to AA square by AB square into amplitude of the A to the amplitude of the B whole square, omega A whole square by omega B square you can take. So A to the B is given as 2, so 2 square in the sense here will be getting as 4 into omega A by omega B will be getting as 1 by 2 whole square. 1 by 2 whole square means 1 by 4 will be getting. So 4 gets cancelled. Here intensity ratios will be getting as IA is to IB, which will be 1:1 you are getting. So this is the correct answer. So let us discuss about the superposition of the waves related questions, students. Here the first question says, if two waves of same frequency and the same amplitude respectively are superimposing produces the resultant disturbance of the same amplitude, the wave differ in phase by. Two waves of same frequency and same amplitude and they are superimposing, they are producing the resultant disturbance of same amplitude. So A resultant, the formula will be getting as A1 square plus A2 square plus, if two waves they are superimposing, 2A1 A2 into cos pi you are taking under, so square you are doing. This resultant amplitude also here it is given as A square, two amplitudes you can take as 2 into A you can take as A square into cos pi. So resultant amplitude also is given as same is given, and here you can this one we just remove, students. Here we will be getting as minus A square, which will be equal to 2A square into cos pi will be getting. A square gets cancelled, minus 1 by 2 which will be equal to cos pi will be getting. Cos pi value will be minus 1 by 2 in the sense cos pi equal to, here you can take as cos 2 pi by 3 you can take, and here cos inverse it becomes, here the phase value will be getting as 2 pi by 3 will be getting. So 2 pi by 3 is the correct answer. Let us take next question, students. When two sound waves with a phase difference of here pi by 2 and each having the amplitude is given as A and frequency is given as omega are superimposed on each other, then the maximum amplitude and frequency of the resultant wave they are asking. So here A resultant here will be getting as it's A square plus here you can take as same amplitude is given, students. Here this is 2A square into you can take as cos pi you can take. So cos phase difference is given as cos pi by 2. It's an under root you can take. And here then resultant amplitude, then the maximum amplitude they are asking. So here you can get it as A square plus A square. This becomes cos 90 will be 0 and this whole thing it becomes 0. So here we will be getting as root 2A will be getting. And now they are asking the frequency. When two waves with the phase difference pi by 2 and each having the amplitude frequency are superimposed on each other, and maximum amplitude and frequency. Frequency here you can take, students, it remains same. Frequency remains same you can take if they are superimposed. Remains same you can take. So here root 2A and here omega is the correct answer. Now let us see the next question, students. Two pulses in a stretched string whose centers are initially at 8 centimeters is given. Here this center and this center. They are initially at 8 centimeter apart or moving towards each other as shown in figure. The speed of each pulse is given as 2 centimeter per second is given. So here it's going to be moving at the 2 centimeter per second. After 2 seconds, the total energy of the pulses they are asking. So here a distance covered in this is here you can take, students, here a speed into time you can take. Here each wave it's going to be moving the 2 centimeter per second velocity, then 2 seconds here x equal to will be getting as 4 centimeter. So after 2 seconds they are asking. After 2 seconds in the sense, students, here one wave is going to be covering 4 centimeters and another wave it's going to be covering the 4 centimeters. Now here the waves they are going to be superimposing like this, and here this amplitude and here this amplitude here it will be same. Then the resultant amplitude of the wave it will be 0. A resultant you will be getting a 0 will be getting. So now the here it's going to be, you won't get any potential energy or elastic potential energy for the wire. So why? Because net resultant amplitude will be 0 will be getting. So generally the total energy they are asking. Total energy is nothing but here will be getting as potential energy plus kinetic energy. So potential energy here it will be 0 will be getting, and here now the string it will be having only kinetic energy. Total energy is nothing but kinetic energy you can get. Means here you can take when they are right, resultant amplitude is 0 in the sense here the particle will be at the mean position you can take at the mean position. So it will be having only kinetic energy, not the potential energy. So the total energy it will be having kinetic energy alone. So purely it is a kinetic energy. Let us see the next question. The next question says here the displacement of the interfering light waves y1 is given and y2 is given. So here it's a y1 is given as 4 sine omega t and here y2 is given as 3 sine. Here you can take omega t plus pi by 2 you can take. What is an amplitude of the resultant wave they are asking? Here the phase difference will be getting as 90 degrees will be getting, students. Delta pi value will be getting as 90 degrees. Then resultant amplitude here will be getting as, this is square root of a1 square plus a2 square will be getting. And here the amplitude of the first wave is given as 4 square plus amplitude of the second wave is given as 3 square. And here you can take as 4 square plus 3 square, it will be 16 plus 9, 25. Square root of 25 means here will be getting as 5 will be getting. So here it is a 5 units is the correct answer. Let us see the next question, students. Here the amplitude of the wave represented by the displacement equation is given. So here y equals to here 1 by root a into will be getting as sine omega t. So here plus or minus 1 by root b into here it's given as cos omega t. Now here they are asking amplitude of the resultant wave they are asking. Now here this is in the sine form, students, and this will be in the cosine form. Here we just change the sine form, cosine form into sine form. Here I am just rewriting this one as sine 90 plus theta. You can write it as sine omega t plus pi by 2. Now these two waves they will be superimposing with a phase difference of pi by 2 will be getting. Now resultant amplitude you can write it as square root of a1 square plus a2 square you can take. It will be under root. So this amplitude here you can take as a1 you can take, and this wave amplitude you can take as a2 you can take. It's nothing but here you can take as 1 by root a whole square plus here you can get it as 1 by root b whole square you can take, which is nothing but here you can take as 1 by root a whole square means 1 by a plus 1 by b you can take, students, under root. So when you are going to be simplifying this one, here we will be getting as a plus b by here we will be getting as ab under root. So here a plus b by ab under root. Fourth one is the correct answer. Let us see the next question, students. Here the two interfering waves have intensities ratios is given as 9:4. So two waves intensities ratios is given as 9:4. The ratio of the intensity of the maxima and minima in the interference pattern will be. So here I maxima by I minima, which will be equal to, here the ratio will be root over I1 plus root over I2 whole square by, here you can write it as root over I1 minus root over I2 whole square you can take. So here you can take, it's a 9:4 it's given, and here root I1 in the sense here you can take, students, it becomes 9i you can take, and here this will be, or else you can take directly instead of right 9i plus here we will be getting as initial intensity, here you can take as 9 times of I2 will be 4 times of the I you are taking, and here you can take as 4i you can take under root by. So here this is 9i and here it will be taken as minus 4i you can take. So this is whole square you can take, and denominator, in both numerator and denominator I square root I whole square if you are taking, and here will be getting as I by I, which is nothing but you can take as this is 3 plus 2 by, here you can take as 3 minus 2 whole square you can take, I gets cancelled. So 3 plus 2 is nothing but 5 will be getting, 5 square in the sense 25 will be getting, 3 minus 2 in the sense here we will be getting as 1 will be getting. So here it is 25:1 is the correct answer. Let us see the next question, and here if the ratio of the amplitudes of the two waves is given as 4:3. Amplitudes ratio is given as 4:3, and here now they are asking the ratio of the maxima to the minima intensity they are asking. So maxima by minima intensity they are asking, and in terms of the amplitude maxima to the minima ratio, students, which is nothing but here we can take as a1 plus a2 whole square maximum intensity, and here you can take as a1 minus a2 whole square you can take. So a1 you can take as here you can take as 4a you can take, and here it will be 3a you can take, and here you can take as 4a minus 3a you can take. So a you can take common and you have to eliminate, and here will be 4 plus 3 will be getting as 7. So here 7 whole square by, here we will be getting as 1 whole square, which is nothing but 49:1 you are getting. Let us see the next question. Find the resultant of two progressive waves along the x-axis is given, and here the resultant waves of two equations they are asking. Now here you can take, students, y1 it's given as this is 3 sine and this is 3t minus 6x is given, and y2 is given as minus 4 cos 3t minus 6x is given, and here resultant of these two in the sense here you can take as, we just add these two values, 3 sine 3t minus 6x and plus into minus, here you can take as minus 4 into cos 3t minus 6x you can take, students. Now with this here I am just multiplying and divided the 5 value. Now here we will be getting as 5 you can take, and this 5 you can take inside the function. Now I am just writing as this is 3 by 5 into sine 3t minus 6x minus 4 by 5, this 5 I am taking inside, into will be getting as cos 3t minus 6x you can take, students. And here just I am giving the triangle, and 53 degrees when you are taking, and here you can take as 4 you can take opposite side, adjacent side you can take as 3, and here you can take as 5, students. Whereas 37 degrees when you are talking this is 37, opposite you can take as 3, adjacent side 4, and hypotenuse you can take as 5 you can take. So from this triangle here you can take as cos 53 you can take as 3 by 5, and sin 53 value will be getting as 4 by 5 will be writing. Now I am just rewriting this equation as 5 into, this is here you can take as sin 3t minus 6x. Instead of 3 by 5 I am writing as cos 53 minus this cos I am writing cos 3t minus 6x into, instead of this 4 by 5 I am writing as sin 53. So now here sin of a minus b, the formula will be getting as sin a cos b minus cos a sin b you can write. Instead of a here it will be 3t minus 6x will be there, and instead of b here it is there 53. Now I am just rewriting this one as 5 into sin, here you can take it as 3t minus 6x, so minus b in the sense here minus 53 degrees you are getting. This is the resultant wave equation. So third one is the correct answer. Let us see the next question, student. The superimposing of the two waves are represented by the two equations is given. The ratio of the intensities they are asking. The ratio of the maximum to the minima ratios they are asking, students. Here a maxima to the minima ratios in the sense I maxima by I minima you can take. Here the first one amplitude is given as, here it is given as 5. Second one amplitude is given as 10 is given. In terms of the amplitude, here you can take as a1 plus a2 whole square by, here you can take as a1 minus a2 whole square you can take, which is nothing but here you can take as 5 plus 10 will be 15 by, so here 5 minus 10 whole square, under root square in the sense it becomes plus only, here it will becomes 5. So here you can take as square, you can take 5 3s are 3 square in the sense here will be getting as 9:1 you are getting. That's the correct answer. Let us take the next question, students. Equation of motion in the same direction is given as y1 is given. So y1 is given as a into sine, it's omega t minus kx it's given, and here y2 is given as a sine, here you can take as omega t minus kx minus theta it's given. So the phase difference between this one and this one here will be getting as theta will be getting. So phi is equal to, here you can take as theta you can take. So theta will be the lagging you will be getting, and here one amplitude will be getting as a in the sense, here one more amplitude will be getting as a, and here it's going to be getting as, this is theta is the lagging angle, phase difference it's given. So resultant amplitude in the sense, here you connect as AR square which will be equal to, so here you connect as A1 square plus A2 square plus 2A1 A2 into cos pi you can take, it's an under root. Both the amplitudes will be same, here you connect as A square plus 2A into A square into cos pi you can take. Instead of pi here it is given as theta it's given. Here this one you can write, students, 2a square plus 2a square into cos theta you can take under root, and here 2a square if you are taking common, here it becomes 1 plus cos theta under root, and here in trigonometry we will be getting formula will be 1 plus cos theta which will be equal to 2 cos square theta by 2. So now AR square which will be equal to 2a square into, this is 2 cos square theta by 2 you can take, it will be under root, 2 2s are 4 under root, it becomes 2, square root of a square means a into cos square theta by 2 you can take, under root will be cos theta by 2 you can take. So here this is a resultant will be getting, AR equal to 2a cos theta by 2 you can get. Let us take on the next question, students. Waves from two sources of intensities is given as I and 4i. They are interfering at a point. The resultant intensity at a point where the phase difference will be pi by 2. The phase difference is pi by 2 in the sense resultant intensity for the two different intensities will be getting as, so I1 plus resultant intensity I2 plus here 2 into root over I1 I2 into here will be getting as cos pi. So here it is given as pi value will be getting as 90. So cos 90 will be 0. This whole thing it becomes 0. So here I1 is given as I is given and second one is given as 4I is given. So I resultant will be getting as 5I will be getting. Let us see the next question, students. Here the next question says here two periodic waves of intensities is given as I1 and I2 passes through a region at the same time in the same direction. The sum of the maximum and minimum intensities they are asking. Sum of the maximum intensity and as well as minimum intensity they are asking, students. Here maximum intensity the formula will be getting as root over I1 plus root over I2 whole square you can take, and plus I minima in the sense here you can take as root over I1 minus root over I2 whole square you can take. Now here it is in the form of here a plus b whole square plus a minus b whole square. So here you can take as 2 of a square plus b square. So here is a plus b whole square plus here you can take as a minus b whole square, which is nothing but 2 of here you can take as a square plus b square you can take. A value will be getting as root over I1 whole square plus, so here root over I2 whole square you can take, students. Here root and square root and 2 gets cancelled here and here. So here the resultant intensity or the sum of the maximum and minimum intensity will be getting us 2 into you can take as I1 plus I2. So this is the correct answer. Let us take the next question, students. Here a sound wave is incident shown. 50% of the intensity is reflected and 50% of the transmitted. The ratio of the minimum to the maximum intensity they are asking. Now that doesn't mean here I is the intensity of the initial wave, students. Here at this point if it is incident means in the total intensity 50% is reflected and 50% will be transmitted. So 50% of the I it will be transmitted means here you can take as 50 here you can take as 1 by 2, that's nothing but here you can take as I1 equal to you can take as I by 2, and 50% is transmitted means remaining the 50% means here it becomes I by 2 will be transmitted. And again here you can take in this again here 50% is reflected like this, and here in the I by 2 50% means here I by 2 into 50 by 100 you can take here 51 or 52 0, so it becomes I by 4 will be getting. This is I by 4 will be reflected, and again in this I by 4 again here transmitted will be 50% is going to be transmitted. In the 50% of I4 in the sense again you can take as 50 by 100 will be getting 51 or 52 0, and here will be getting as I by 8. So transmitted intensity I2 value will be getting as I by 8 will be right. So this is I1 value you got it as I by 2 and I2 value you are getting as I by 8 you are getting. Now they are asking here I minima to the I maxima, they are asking the relation, which is nothing but I minima is nothing but root over I1 minus root over I2 whole square by here you can get it as root over I1 minus plus root over I2 whole square you can take, students. So root over I1 it's given as I by 2 under root plus this is I by 8 it's given under root whole square by here you can take as I by 2, sorry this is minus value, root I by 2 plus here you can take as root I by 8 you can take whole square you can take. Now here when you are simplifying this one I by 2 you are taking common, so root I by 2 if you are taking common here you can get it as in numerator 1 minus, and here it will be I by 8 into here you can take it as 2 by I when you are taking common. This is here you can take it as whole square you can take, students, by again you can take root I by 2 if you are taking common in denominator, this is 1 plus, and again you can take it as I by 8 into this is 2 by I. So here I this is here you can take it as I by 8 by here you can get it as I by 2 when you are taking common. So here it becomes I by 8 into 2 by I you can get. So this is whole square you can take, so whole square you will be getting. So this root I by 2 and root I by 2 gets cancelled in both numerator and denominator. Now here you can take this here I and I gets cancelled, 2 4 times it is getting. So square root of 1 by 4 in the sense 1 by 2 will be getting. So it's 1 minus 1 by 2 whole square by in denominator will be getting as in the same way this IA gets cancelled 2 4 times This is an under root. So here we will be getting as 1 by 2 whole square you are getting, which is nothing but 1 minus 1 by 2 is 1 by 2 whole square by, here it is 3 by 2 whole square you are getting. Therefore I minima to the I maxima value, which will be equal to 1 by 2 whole square means 1 by 4. When you are bringing into the numerator, it becomes 2 by 3 by 4, 3 by 2 whole square. So it becomes 4 by 9 will be getting. 4 gets cancelled. It is the ratio of 1:9 you are getting. Now let us see the next question, students. Here 3 waves is given of equal frequency, having the amplitude is given as 10 meter and 4 micrometer and 7 micrometer, arrive at a given point with successive phase difference of pi by 2. The amplitude of the resultant wave in micrometer they are asking. So here 3 waves is given, students. Here you can take the resultant of 3 waves you can take as YR equals to, so one you can take as 10 micrometer into, here you can take as sine omega t minus kx you can take, and the second thing is here it is given as 4 into sine, so omega t minus kx plus pi by 2 is the phase difference you can take, students, plus, and 7 micrometer into sine omega t minus kx plus pi you can take. So here why I am writing in this sense, here with the successive phase difference of pi by 2. So all the 3 waves they are going to be moving between these two, here pi by 2, and again here between these two also will be getting as pi by 2. That's the reason I am writing like this. So here sine 180 plus theta, sine 180 plus theta will be getting as minus sine theta, then YR equals to 10 sine, so here you can act as omega t minus kx plus 4 into sine omega t minus kx plus pi by 2, and this will be 180 plus theta will be minus will be getting, so here you can act as minus 7 sine omega t minus kx will be getting. And here this is 10 sine omega t minus kx, and this is minus 7 omega t minus kx. 10 minus 7 will be getting as 3, so 3 sine omega t minus kx plus here will be getting as 4 sine omega t minus kx plus pi by 2 you can take. These are the 2 waves. Now they are superimposing with a phase difference of pi by 2. Now they are asking the resultant amplitude AR, which will be equal to A1 square plus A2 square plus, here you can take as 2A1 A2 into cos pi you can take. Cos pi in the sense cos 90 will be getting under root. So this value will be 0, cos 90 will be 0, and here A1 square plus A2 square means 3 square. So here 3 is the first amplitude and second amplitude will be 4, and here it is 9 plus 16, square root of 25 will be getting, AR equal to will be getting as 5 will be getting. Now let us see the next question, students. Consider 10 identical sources of sound all giving the same frequency, so but having the phase angle which are in the random directions, and if the average intensity of the each source is given as I0, the average of the resultant intensity I due to all these 10 sources they are asking. Resultant intensity formula, students, here IR equals to conductor, so I1 plus I2 plus 2 root I1 I2 into you can take as cos pi you can take. So here pi is phase difference is going to be varying randomly, it's given, it varies randomly. So randomly when it is varying in the sense, here students, average of this all the pi values here you can take as 0. So cos pi average you can take as 0 you can take. That doesn't mean here we will be getting as for 2 waves the resultant intensity here will be writing as I1 plus I2. Both the intensity is given as same is given. So here we will be getting as 2 I0 will be getting. So for 10 waves in the sense, 10 identical sources in the sense, for 10 identical sources, so here you can take as IR equals to you can take as I0 plus I0 plus I0 plus and so on 10 times will be getting. Here it is I0 plus I0 plus and so on, here you can take as plus 10 times of I0 you can take. Therefore resultant intensity will be getting as 10 times of I0 you can take. Let us see the next question, students. In the figure, the intensity of the waves arriving at the point D from 2 coherent sources S1 and S3 is given as I0. The wavelength of the wave is given as lambda equal to 4 meter. The resultant intensity at the point D will be there asking. Now here the path difference you have to take, students. Here delta x, which will be equal to, here this is s1 to d and here it will be s2 to d. There is a path difference, extra path covered by the s2 wave you can take. So path difference when you are taking s2d minus, here you can take as s1d you can take, which is nothing but this is 3 and 4 in the sense, here we will be getting as 5 meters. S2d will be getting as 5 minus S1d will be getting as 4 meters you will be getting. So 5 minus 4 will be getting as 1 meter will be getting. Now here the wavelength is given. Now here you can calculate phase difference value. Delta phi equals will be getting as 2 pi by lambda into delta x you can take. So 2 pi by here lambda is given as 4 meters is given. 4 into delta x value, path difference is 1 meter, and here you can take as phase difference value you got it as pi by 2. Now the wavelength resultant intensity they are asking. Resultant intensity formula here IR equals to I1 plus here I2 plus 2 into root I1 I2 into, here you can take as cos pi. Pi value will be getting as pi by 2. Here you can take as cos 90. So this becomes 0 and here I1 plus I2. So here both will be having the same intensity is given. It's nothing but I0 plus I0 you can take. So here I resultant will be getting as 2 I0 will be getting. So 2 I0 is the correct answer. Let us see the next question, students. Here two waves y1 equal to a1 sin omega t minus beta 1 and sin a2 into sin omega t minus b2 superimposed to form the resultant wave whose amplitude c is given. So here they have given us phase difference you have to calculate, students. Delta phi 2, this is the initial phase you can take pi 1 and this will be the final phase, second phase you can take delta phi, which is nothing but you can take as pi 2 minus pi 1, which is nothing but omega t minus b2 minus omega t plus b1 you can take. So here omega t gets cancelled and here will be getting as phase difference will be getting as this is b1 minus b2 you will be getting. Now here you can take resultant amplitude in the sense, a resultant here what you can take, students. Here is a1 square plus a2 square plus 2a1 a2 into you can take as cos pi, it will be under root, which is nothing but here you can take as a1 square plus a2 square plus 2a1 a2 into cos pi. Cos into pi value you are getting as phase difference is beta 1 minus beta 2. So this is a resultant amplitude you can take. A net equals square root of a1 square plus a2 square plus 2a1 a2 into cos beta 1 minus beta 2. Let us see the next question, students. Two waves are represented by y1 equal to a sin omega t plus pi by 6 and y2 is given as a cos omega t. What will be the resultant amplitude they are asking? So here y1 is given as a sin, its omega t plus pi by 6 is given. And second equation it will be in the cosine form it's given. You just convert into the sine form to get the phase difference and all. So a into you can take as sine. So 90 plus theta you can take, which is nothing but sine omega t plus pi by 2 you can take, which is nothing but cos omega t will be getting. Now phase difference when I am talking here you can take directly, this is pi by 2, pi 2 minus pi 1 will be getting, this is pi by 6 you can take, which is nothing but take LCM 6. So 2 3s are and here will be getting as pi. So here 3 pi minus pi will be getting as pi will be getting, and here 2 pi by 6 in the sense here will be getting as pi by 3 you are getting. Now here you can take resultant amplitude, students. Here AR which will be equal to, it's nothing but a1 square plus a2 square plus here you can take as 2a1 a2 into you can take as cos pi you can take under root, which is nothing but a square plus 2 into a will be getting as a square into cos pi by 3 in the sense here we will be getting as cos 60 will be getting. So cos 60 is 1 by 2. So instead of this one here you can take as 1 by 2. That means here we will be getting as 2a square plus 2 into a square into you can take as 1 by 2. 2 gets cancelled. 3a square will be getting. It's nothing but amplitude which are equal to 3a square under root here. So amplitude resultant amplitude will be getting as root 3a will be getting. So root 3a is the correct answer. Now let us see the next question, students. This is from the reflection and refraction of the waves is given, and here it is given as y equal to, it's given as a sin here kx minus omega t is given plus theta it's given, and here it passes from a heavier string to the lighter string. This is the heavier string you can take, student, and this will be the lighter string you can take, and here this is the free end you can take. So this will be the denser medium you can take, and this will be the rarer medium you can take. So here the equation of the reflected wave they are asking. Equation of the reflected wave in the sense here the wave is reflecting from the rarer medium, so there won't be any phase difference will be getting, students. So reflected wave equation, when I am writing in this sense, here you can write as y dash, which will be equal to, so here amplitude will be getting as here the reflected wave has an amplitude is going to 0.5a, so 0.5a into sine, here you can write as this is, so minus kx we can take plus omega t plus theta you can take, plus theta you can take, and here minus, when you are taking common, here you can take as minus 0.5a into, here you can take as this is sine kx minus omega t, so here you can take as minus theta you can take, students, here kx minus omega t minus 0.5a into sine this is kx minus omega t minus theta will be getting. So this will be the correct answer, students. Here there is some right here it's not given, so there won't be any phase difference when it is reflecting from the rarer medium, and here this will be here it becomes kx, it becomes minus, and here if you are taken this is also minus, here this is, so now here this is also minus you can take, students, here it will be minus kx, and here it will be kx plus omega t minus theta will be getting. So yes, here it will be minus 0.5a into sine kx plus omega t minus theta. This will be the correct answer. Now let us see the next question, students. Here a wave is traveling along the positive x-axis is given by y equal to a sin omega t minus kx. If the reflected wave from the rigid boundary is such that its 80% of the amplitude is reflected. So 80% is reflected means here amplitude of the reflection which will be getting as 80% of initial a value, here this is nothing but 0.8a you can take. So here a reflection from the denser boundary it's given, reflection from denser boundary your documents, from denser boundary. So now the phase difference value will be getting as pi will be getting. The given equation is incident wave equation is given as y equal to a sine, here omega t minus kx you can take, and here reflected wave equation, this is an incident wave, and here reflected wave angle of incidence you can take a, reflected wave amplitude of the reflection into sine, here you can take as omega t plus kx plus phase difference will be getting as some pi will be getting. So sine 180 plus theta will be getting as minus sine theta minus ar into you can take as sine omega t plus kx you can take. So here ar value we calculated as 0.88, so here minus 0.88 into sine, here you can take as omega t plus kx. So this is here minus 0.88 sine omega t plus kx is the correct answer. So just look at this. Look at the next question, students. Here in the figure A, it is incident pulse, and here A, B, C, D are the possible forms of the reflected pulse. Tick the correct answer they are asking. So if the A is reflected from the resident, so reflection from the resident in the sense, so reflection from resident you are taking means from resident. So there is a phase difference of here will be getting as pi. Suppose a reflection from the yielding surface means smooth surface you can take, from yielding surface, here will be getting as it's a free end you can talk, student, there won't be any phase difference. So here the diagrams will be reflecting as here we just look at B is the thing you will be getting, so here is reflected from the yielding surface, here there won't be any phase difference, the wave will be reflected back in the same direction with the same right amplitude. And D, when you look at here, D is reflected from the rigid wall in the sense D it's given as here you'll be getting as the phase difference value will be getting as 180 degrees will be getting. So here you just imagine this one, students, while the wave is reflecting, You just imagine here one mirror is there, you just imagine, mirror you just imagine, and here you can talk about the reflection. So reflection, if you are talking in the mirror, if you are imagining, there's a mirror you just place like this. Here there's a mirror you just imagine. Now the reflection you will be getting from the yielding surface, you will be getting second option, and here from the rigid surface you will be getting as fourth option you will be getting. So both here B and D are the correct answers. Let us take the next question, students. Here it's given as a wave pulse and a sting is given as dimension shown in figure. The wave speed is given as v equal to 1 centimeter per second. If the point O is at the free end, the shape of the wave at time t equal to 3 seconds they are asking. So here at time t equal to 3 seconds they are asking, students. Here right. Here you can take, here the wave is given like this, and here this amplitude is given as 1 centimeter, and here it's given as 1 centimeter, and here also it's given as 1 centimeter, and here you can take as, this is a free end you can take, and here it's given as 2 centimeter it's given. Now here you just imagine like a mirror, students. Here the wave when it's going to be moving, and here its velocity is given as, here 1 centimeter per second it's given. That means here in every 1 second it is going to be covering 1 centimeter, and here if you are taking this image on the right side on a mirror, if you are imagining, and here the wave is moving like this, and this wave also will be moving towards this surface like this, and here the moment when it is covering t equal to 3 seconds, in the sense at this point here it will be, so here at this point here, so here this is the wave, this is the incident wave you can take, and here reflection of the wave will be getting as, here you will be getting, here it will be imposing like this. So here now this amplitude here it becomes 2 centimeter will be getting, and this will be 1 centimeter will be getting. So the fourth option here it will be like after 3 centimeters, students. Here one portion alone, here you can take this portion. So this is a portion will be at 3 centimeters will be getting like this, and here it will be imposing on the same this one, and here will be getting as 2 centimeter will be getting this together, and here you will be getting as, this will be, here will be getting as 2 centimeter and 1 centimeter will be getting. So fourth one is the correct answer.